Okay, so I think today we're going to be working on our wave 2. So right now wave 1 is 3 vultures at bounder level, which means they're red. But if we could kill all of them and collect all their eggs, we need to go to wave 2. So where are we using this times egg hatched? Okay. So the tricky thing is we've got a bunch of things locked in at 3. A bunch of for loops locked in at 3, and that's because wave 1 has 3 enemies, but there could be up to maybe, I don't know, 12 bad guys. So this number needs to be adaptive, depending on the wave we're in. Oh, jeez. Okay. I did not do my homework where to figure out all the different waves, but I still got to do that. We take a look at our notes. I say, research how scores are calculated in the original. So yeah, we've got to work on that. We could start to add the wave first, since I did not do that homework. So I guess we'll work on it. So instead of this table getting initialized with 3 values, it needs to get initialized with the amount of enemy objects. Now, I think we gave ourselves an enemy object integer. No? Thought we did that yesterday. What is this refresh lore? Okay, we're not using this refresh, so that must be an old thing. What's happening? Yesterday we did something like this. We check the beginning of our update. We have... Oi, oi, oi. Thought we gave ourselves an enemy object variable, but it looks like we don't have that, so we need a variable called enemy objects. Now, it's fine to init at 0, but in our update here, we need to ask, you know, what wave we're at. Well, I guess we've already got that line here. Wave 1. So here we can say enemy objects. Oi, oi, oi. Enemy objects gets 3 for wave 1. Now, this needs to be replaced with an enemy. What did just happen? So if it's wave 1, we get 3 enemy objects, and then we insert 3 print score objects into our scores table. And then we become wave 1 score populate. Gets true. Now, this is still in the wave 1 logic. Yeah, we really, okay. So, this should give us 3 print score objects. We need this to also be enemy objects. So now we're instantiating an empty vulture. Well, not an empty one, but one in the graveyard at the index I after we're cycling through all of our enemy objects. And then we become tables populated. Now, what do we do with tables populated? Well, what we do with it is we only instantiate our vultures if we are not already having our tables populated. Okay. Okay. We start decrementing our pterodactyl spawn. And if it is smaller than 0, then we're gonna take the pterodactyl out of the graveyard. And then we're gonna decrement our vulture spawn. See, so here, we need, see, this is a little tricky because this is fine for wave 1. Yeah, there's gotta be a smarter way to do this. Because this is wave 1, which is spawning the right amount of vultures, which is fine. But at the end of wave 1, we need to check whether or not all of our eggs are collected. So if it's wave 1, we're going to say we have to check all of our eggs. So we're going to say for I gets 1 comma enemy objects. So we're going to search. We're going to do a for loop for all of our enemy objects here. Can we not do a for loop like that? Why does it mess that up? What is going on? Why is everything blue here? Oh, we need it inside our loop here. That's where we need it. And not then, but do. Cool, okay. Now, it's almost like we need, how do we check to see if every single one is, every single one of our enemy objects needs to have an egg that is collected. So we need, we either need a little boolean called all eggs collected. What do we do here? Yeah. It's like simple, but it's not simple. I'm just missing it. Because we have to say, sure, is enemy, you know, if enemy, or if eggs at our index of I dot collected is equal to true, we need to check. We need to check up to and including the last enemy object. So we could say we could just say if eggs1 is collected, check eggs2, and if that's collected, check eggs3, and if that's collected and that is the number of our enemy objects, then we're going to go ahead and say wave gets equal to 2 now. We could do something like that instead of a for loop. Because the problem with the for loop here is we're checking the first one, but we don't have a way to signify and check the second one only if the first one's true, and the third only if the first and second are true. So I'm kind of thinking we do it differently and say if eggs at index 1 dot collected, then we're going to ask if eggs2 is collected, but we need a way to kind of only check the amount of enemy objects we have. So if enemy objects is 3, oh, you know what? We could do a kind of decrement. Yeah, we could do a decrement instead. So we can say, how about for I gets our amount of enemy objects, and then we're counting until 0, and we're going to decrement by 1. So now we can say we start off at, keep doing that. We start off at our enemy objects index, so the topmost egg. We're seeing if that's collected. But then how do we check the smaller index? I don't know how to do this. I guess, well, see the fact that I don't know. We need some kind of recursive thing, I think. I'm not good at recursive things. Yeah, how can we do this? I'm sure I'm overthinking this, but I just don't know what to do. You know, we're trying to... I mean, we could do this, I don't know. Like, we could have a table, so like, you know, we can have a table called, eggs popped. It's a table of all zeros because there's no egg popped, but if it's popped, it's true, it's 1. And then anytime our egg gets collected, we change our table at the same index of our eggs popped to get equal to 1. Then we have a for loop cycling through all of our eggs popped, and if all of them are 1, it's the same problem though. How do we cycle through and ask if every single thing in a list is true? I don't know. Well, we're still spawning our 3, even though we switched our enemy objects. So that's a good sign. That egg shouldn't have been double points because it touched the ground. Not exactly sure what to do here. What we could do is check, you know, if eggs at our first index is collected. Then we're going to go ahead and check the next one. But I think we can't have less than 3, so we should just worry about 3. Then we can worry about expanding it, I guess. But then if eggs 2 collected, then if eggs 3 collected, then this is in wave 1, so we could go ahead and do this for wave 1. We say at this point all our eggs would have to be collected, and then we can say wave gets assigned 2 at this point. So that's one way of doing it in this first wave here. It's not very expandable. But that should at least work. Now, if we debug info, if we print up wave number, wave, and we say we're gonna concat, nope, it's not what I wanted at all. Wave. Okay, then we need to concatenate to a string our wave variable, or wave integer, concatenating that to a string, turning it to a string, then concatenating it with wave, and then we're gonna put it at the top of the screen here. We're at just 10 pixels over, 10 pixels over, 10 pixels down. What just happened? What the heck? Okay, X is 10, Y is 10, and we can delete the rest. Let's see. Wave 1 currently. Now, if we collect all the eggs from these guys, all 3 of them, we should become wave 2. Wave is still 1. Now, as soon as we get this last egg, wave 2. Okay. So we've got wave 2 working. It's just really ugly. Because if we look at this, all we're doing is in wave 1, we're checking. It's ugly because we know that there was 3 enemies because our enemy objects was 3, but we're doing a nested if condition, cycling through all the eggs, and only if every single one of them is collected do we become wave 2. So there's got to be a better way to do that, because we're going to have maybe 10 waves, and I don't want to just have to manually put in nested if loops like this. So I want to think of a better way to do this. So that'll be my new homework. We'll say okay. So yeah, there's got to be a better way to do that. So we've got wave 2, we've got our variable wave 2 to become, we've got our variable wave to be assigned to if we've gone through all of our eggs in our wave 1 and all of them have been collected. But there's more stuff that we're using a 3 for, just like this. Yeah, be sure to change 3 to a variable for wave objects. So we've got that. We've got that. This is actually enemy objects. Oh my god. So we can say it's not what I wanted. Do we have any other magic 3s in here? Yes, we do. We've known we needed to change this for a while now. So depending on what wave we're on, gives us a... We have to make sure to spawn the appropriate amount of enemy objects depending on which wave we're in, and then we're checking all these values for every object. Which I can imagine can get pretty taxing when there's 12 vultures on the screen. But we'll have to see. Yeah, we've got a bunch of hard-coded 3s here. Now, oh my god, really? How do I keep doing that, man? Okay. I think that's the last of it. Let me just make sure we're not crashing. Looks okay. Gotcha. Okay. But look, no wave 2. Sure what? You know what? Okay. This is actually, yeah. This is only checking if the egg's been collected. So when we get a jockey, when we collide with a jockey, we need to say, once we send our jockey to the graveyard, so we can search for graveyard. Well, we're actually going to be doing this in the play state, so when we send our jockey to the graveyard, we need to assign our egg to be collected, which we are not doing. Where is, oh here, jockey graveyard. Oh, that's false. Jockey graveyard gets true, where is that? Here. Cool, so all we have to do is when we send the jockey to the graveyard, we need to change our eggs table at that same index. We need to change our collected field to get true. Therefore, we can become a wave 2 if we collect the jockeys and not the eggs. Because that would mean we collected all the bad guys. But we were just asking about eggs collected, which isn't technically the right solution. So now, let's try this with a jockey. I'll let a jockey hatch. Oh no, okay. I'll let a jockey hatch and I'll go get him. And we're wave 2. So that fixed that bug. So we still need to make it prettier, and then our eggs collected. Yeah, I want to make this prettier, but we do have a wave 2 detect working now, and it works whether you collect the eggs or collect the jockeys, so we're at least about ready to spawn our wave 2 stuff. I just want to figure out our print score objects for each wave and what might be different, so I've got homework to look up how the original handles that. And then we can go ahead and start actually spawning our new vultures for our different wave 2. And then I want something a little more elegant than this. This could work. It would just mean I'd have to do this for in every wave. I need to check. There's a better way to do this. I think, you know, we've got enemy objects variable that's counting how many we need to have all their eggs collected, but we don't have a very elegant way of doing that. So maybe we'll write a function is all of the eggs. Yeah, we'll just write a function to that says, you know, maybe we pass it in. Well, when do we want to call it? We want to call it every frame, and we need to check if all of the enemy objects have their .eggs collected, and if so, we need to increment our wave. So yeah, we can do that. We'll probably just do a function like that. Shouldn't be too hard. So what we did today was, yeah, really just factor out our magic number for the amount of enemy objects we have, and then we've got a wave 2 detection, but we're gonna be shifting that so that we can use one function for all of our waves and determine if we need to increment our wave or not. So I'm gonna say we about all we did. We've got okay. So I've got homework to do, and then we'll continue on with the correct hopeful print score object lowest egg value stuff, because I have to research how the original does those scores so that we're getting the right scores, and then we can work on the actual vulture instantiation for our wave 2. Then we can work on the rising lava. Then we can work on, you know, the text on screen. Eventually we'll have to add the sounds for the vulture spawning and everything, but we'll get there a little later, I guess. But yeah, catch you guys tomorrow for some more programming.